There is one more type of reinforcement of, so to speak, in slope W. This is could be either a pile or dowels. Fundamentally, it provides a shear resistance or increases the shear resistance. We can briefly illustrate this with GeoStudio. File, open. It is SLP 26. If we say draw reinforcement load and click on this pile, you can see that once again there is a spacing of the piles, and then you as the user, you have to specify this shear force, and you can have a factor of safety on this shear force. Specifying this shear force is the difficult part of this analysis. We at GeoSlope cannot offer you any guidance on what the magnitude of this value should be. You would likely have to start working perhaps with a structural engineer. I want to point out to you this option here, that this shear force can be specified perpendicular to the reinforcement, or alternatively parallel to the slice base. So very quickly then, going to the results view, and we say view slice information, and we take a look at the slice that encompasses the pile. Once again here you can see that we have this shear force here that is included in the factor of safety calculations. So once again, this is a form of a reinforcement where the slip surface might go through the pile or the dowel, and you as the user can represent this shearing resistance with a shear force. Now if the slip surface goes underneath the pile or the dowel, then of course there is no force. But if it goes through the pile or dowel, regardless of the position, it doesn't matter if the slip surface is here, 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 anywhere, the magnitude of the shear is the same. So this is a rather crude approximation, and as I have already said, the difficulty with this approach is coming up with the magnitude of the shear force that you can rely on for design. Just a few comments on wall facing. Clearly there is need for some form of a wall facing to prevent soil from unraveling between the nails and the anchors and so forth. But the wall facing is not included in a slope W analysis. That is a separate issue. So we deal just with forces that arise from either breaking the reinforcement or from pulling out the reinforcement behind the slip surface. So that slope W deals with the breaking strength of the reinforcement, or it deals with the pull-out behind the slip surface. If there's a slip surface like this, we do not deal in slope W with the possibility that the soil might slide past the nail. We only deal what's behind the slip surface, not in front of the slip surface. So in summary, wall facing is important, but wall facing does not come into a slope W analysis. So our suggested approach with reinforcing is that you start by answering the question, how much force is required to achieve a desired factor of safety? Use a simple concentrated line load if necessary, or model as an anchor with a constant option to start with, and make nails and fabrics very long until you are comfortable with the mechanism, then see how much you can shorten them. These are all techniques to help you answer this question here. So we recommend that you should confirm the data using hand calculations. Throughout these presentations on reinforcement, we have done a lot of spot checks with hand calculations. You should be comfortable doing this in order to use the reinforcement in slope W. And as we have done throughout this presentation, make frequent use of the View Reinforcement Info command and confirm your desired effect using View Slice Info, as we have done in all of these examples. We cannot overemphasize the importance of doing this as part of the interpretation of the results. Also, be very careful about multiple modes of failure. And again, we must look at more than just the factor of safety. You have to approach reinforcement problems very methodically. You cannot dump all the information into the analysis at first and expect to get the final answer right off the bat. Usually you have to go step by step and be able to interpret the results and do some spot checks by hand calculations to be confident that you have gotten the answer that you need. One last issue in these types of problems, if you use the grid and radius approach, you will notice that there is a large area here where you cannot get an answer. Moreover, the one with the lowest factor of safety is always close to ones where you cannot get an answer, and this is somewhat disconcerting at first, but without going into a lot of details, we have discovered from using finite element sigma W results that in spite of this non-convergence, this is still an acceptable factor of safety. So I don't have the time here to go into all the details, but don't get too excited or too concerned about getting your factor of safety, the lowest factor of safety, next to ones for which you cannot get convergence. The difficulty is with very, very steep slip surfaces. This area here represents some very steep slip surfaces. And the critical slip surface often tends to be one that is the steepest for which you can get a factor of safety. This brings us to the end of our discussions on concentrated loads and reinforcement loads in slope W.